So my name's Kevin. My name is not, is it? Well, I guess it's part of the email address. So my name's Kevin, Kevin Jones. Email address, Twitter. I've put my GitHub account up there. The demos I write today, I'll stick them on GitHub under that account. You'll find them on like Software Architect 2013 or something similar. It should be fairly obvious where they are. Yes, we'll write some code as we go through this. I work for, I'm self-employed. I work for various companies. I do training for Developmentor and Rock Solid Knowledge, which is my email address. We do consultancy, development, training, a whole bunch of stuff. For the last 18 months or so, the major work I've been doing is on a project building what started out as an MVC application for a customer and morphed into a massive JavaScript application with some MVC stuff on the back end. So it's essentially a single-page JavaScript app. So I spent the last 18 months sort of elbows deep in JavaScript, doing various bits and pieces with that. Hopefully, some of that experience I'll talk about today. At least some of the things that have come out of that. We'll talk about here. As we go along, any questions, please ask. If you want to save them for the end, that's fine as well. But don't feel you have to. Just if you have questions as we go through this, then I'm more than happy to take them. So, how many people are doing JavaScript now? JavaScript code now? Nearly everybody. Okay, cool. How many people are writing JavaScript tests now? 2, 3, 3.5 people. Okay. Right, so we're going to cover a few bits and pieces. We're going to talk about some general, why do we test? Yeah, so why do we care about testing? And that applies to JavaScript, but it also applies to anything else as well, to any other sort of code. Yeah, so it's just sort of general stuff. And then we'll take a look at some frameworks, some unit testing, or some testing frameworks, in fact, in JavaScript, not necessarily just unit testing frameworks. We'll take a look at QUnit, which is the one that's used by Jquery to do their testing. And we'll take a look at Jasmine. Yeah, and Jasmine's more of a sort of behavior-driven development, a BDD-style framework for JavaScript. And really, they're the two testing frameworks. This one, which I'm still not sure how to pronounce, I think it's pronounced Xenon, but I'm happy for somebody to tell me it's pronounced differently, is a mocking framework for JavaScript. Which, in JavaScript, if we do mocking, we don't really need a framework. We can do it ourselves, but it just makes life slightly easier. So we'll see what that is and how that works and where it fits in. And then, lastly, the order we're going to do this is going to be QUnit, Xenon, and then Jasmine, and then this thing called Karma. And Karma is a continuous testing tool for JavaScript. So you can kick it off. It runs in the background in a console window. It looks at your directories with your test files in and with your JavaScript files in. And when you edit those files and save them, Karma runs your tests automatically in the background. So you just have these tests constantly ticking over. So I'm going to go to a tool and go, no, run this. It's just there for you. I'm running all the time. Yeah. These tools all run on Windows, Linux, Mac, so whatever you want. I'm doing the talk. I'm running a MacBook, but I'm doing the talk under Windows here today. So how many people are doing development under Windows as the OS? Okay, nearly everybody. Anybody using Mac for the development? One guy. Linux? One guy. Okay, so these are all the same across all the platforms. Yeah, which is nice. So the idea behind test-driven development is that we want to use the tests to drive the code, not the other way around. So this idea of writing tests first, rather than writing code first. And the idea is that the tests help us define the requirements. Or in fact, in many cases, depending on how we write the tests become the requirements for the code in many ways. So you can write the tests in such a way that they specify what the code should do, and then you write the code to satisfy the test. And there's a few ideas, a few sort of concepts behind that, I guess. The test also becomes sort of documentation for the code, depending on how you write these things. But the other thing is, if you write the code first, then you end up writing the tests that make the code pass. So you sort of write some code and go, I need a test for this. So you then write a test and just make sure that code is okay, which is almost is in many ways the wrong mindset. What you want to try and do is think of the specification, write the specification, and then write the code until it passes that specification. And that's the sort of idea behind writing the test first for this stuff. Now, there's a couple of approaches to this, I guess. One is don't write any tests. Many of us do that. One is to write all the code first and then write some tests later on. One is to do a little bit of code, a little bit of testing, and one is to do the test and then write some code. Yeah. And I probably fall into the last two of those more often than not. Sometimes I'll write some tests first and then write the code to go along with that. And sometimes I'll write the code first and do some tests to check my code. Yeah, I'm lazy, right? As we all are. Yeah. How many people pair program here? Pair program? One or two. So pair programming for testing is great because that pairs the guy on your shoulder going, write a test, write a test, write a test. Whereas now I was chatting to you and you say you work at home. I work at home mostly as well. So I work on my own. And I never have anybody there going, you should be testing now, you should be testing now, right? So, but it's important at some point, have somebody tapping you on the shoulder, this voice of conscience going, write some tests. Yeah? Otherwise, I've got to be careful because I'm being recorded, so I can't swear. This is going to be difficult. So the idea is with the tests, drive what the code is. So I'm sure you guys have come across this before. This concept we have of red-green refactor. You write the test, tests fail. Most test runners, when they fail, turn something red. Either the text output saying your tests have failed, or status bar saying tests have failed, or something that indicates that the tests have failed. So red means failure. You write the code so that the failure goes green. The tests go green. Yeah, they're now passing rather than failing, and then you refactor the code. Yes, you have one run at it, and it works, and make sure it works okay. You're looking to go, not quite sure about that, and then you work on improving the code, the refactoring. Yeah. And refactoring could be adding more features, making the code do what it's supposed to. But you constantly go through the cycle of sort of red-green refactor to try and get the test to work. Then is it write enough code to pass the test? That we can get silly with this, as we'll see in a second. We'll write some code in a second. We'll see. You can sort of get silly going, well, we'll see. Yeah, that doesn't necessarily mean write the smallest amount of code that you can. Yeah, so no, be sensible. But what it means is don't add 2 features when you only need 1 feature to make the test pass. Yeah, and again, we'll dive into that in a moment and do a bit more details on that. Refactor to clean up the code, remove redundancy. Yeah, so make the code easier to read, easier to understand, easier to maintain, and keep running the tests. Yeah. And you sort of go around this circle, this loop going, write the code, run the test, write the code, run the test, and hopefully constantly improving the code. Why test? Well, I've been writing code and tests for a while now. I'm trying to think how far back, 15, 20 years, maybe even more than that. Not necessarily in a sort of standard TDD style, but certainly trying to follow those sort of principles. And the primary benefit for me, I think, is probably this one here. This reduction of uncertainty. Yeah, so our current code base, I hate to say it, but on our current code base, we have a lot of code that's not covered by tests. I'm in the process at the moment of heavily refactoring that code, and I always feel very nervous when I go near it, trying to pull stuff out because there's no test. I have no proof at the end. You can't prove the code is 100%, but you can prove that you at least haven't broken anything that was working before, as long as you have good test coverage. Yeah. And that's what tests give me, is the confidence to refactor the code, knowing I haven't broken anything inside it. And if I don't have tests, I feel very, very nervous. And if I don't have tests, it takes me a lot longer. So I have to go in, change the code and then examine the code by hand and make sure everything's okay, and then write it inside the browser and make sure that's okay, and sort of go, well, I think that's all right, and then check it in and hope nobody else goes, Kev, this thing that was working is now not working. Yeah. And obviously that happens frequently. So I think that's the primary benefit of testing to me. Yeah. Just giving me that degree of confidence within the code itself. There are different sorts of tests. Yeah, so people talk about unit tests, and we talk about integration tests, and acceptance tests, and different sort of levels of testing, if you like. Unit testing is all about testing that one small feature, the one small thing that you want to work. The thing with unit tests is they should be quick and they should be independent. So I should be able to take my unit tests and run them in any order. Shouldn't matter. Yeah, and they don't. It doesn't matter. Like, I don't have one test that cares about another one that's previously run. Yeah, so I'm going to test to put something in a database, then another test to test that it's there, because that's order dependent. Yeah, so unit tests should run in any order. They should be quick. If they're not quick, I'm not going to run them. Yeah, so we want these things to run as quickly as possible as well. Yeah. So there's a set of rules. So Michael Feathers, who's one of the godfathers of all this stuff, I guess, and we're heavily involved in the agile space and testing space, came up with this set of rules. And basically, what they say is, these tests, unit tests, are isolated. You know, they shouldn't touch any physical things. Don't touch the file system, don't touch the network, don't touch the database. If they do that, they're not unit tests. Those tests are valuable, yeah, but they're a different sort of tests. They're integration tests, if you like. Yeah, so unit tests should be completely isolated, completely standalone. Yeah. And we'll see, in JavaScript, we're going to write code that wants to talk back to the network, to our server, to our web server. It's like, well, if I do that, I want to be able to do that without touching the web server. Otherwise, it's not a unit test. So how do I do that? So we'll talk about how we can achieve that. And that's where things like mocking tools and mocking frameworks come into play. So we'll cover that stuff as well. So, tools. Many, I'm sure there's many more than I've listed here for testing. So we'll take a look at QUnit. That's the one that's come out of Jquery. We'll play with that in a sec. Another one called Buster. Karma used to be called Testacular, okay, but that obviously wasn't politically correct enough. So they changed the name to Karma. Test Swarm, JS Test Driver, the Yahoo one, Yeti, and Jasmine, which is this BDD tool, and Xenon, and many others. So you have a huge choice, okay, in the Java space. Okay. So QUnit was originally written, I believe, by John Resig. John Resig is the guy that wrote Jquery originally. And it was written to help test Jquery. He was part of Jquery. It's now spun off into its own library, and you can just go and grab this thing and download it. It's up on the Jquery CDN site. There's no dependencies on Jquery. So you don't need Jquery installed to use this as your test tool. Yeah. And it's a very, very simple tool. Yeah. So you set it up. Well, it's got some setup. You've got to go in and include a CSS file and some JavaScript. Yeah. And within the HTML, you need a section of the HTML to tell it where to display the test results. So the setup for this thing is really, really straightforward. And you end up writing, using this, some tests, and we'll come into this in a sec, and then some code to test. Yeah. And the output looks something like this. Yeah. So fairly simple output that runs in a browser. So the tests need to be loaded into the browser and run inside the browser. Yeah. Which may or may not be an issue, depending on exactly what you're doing inside this code. Yeah. So I think what we're going to do is we're going to write some code. So let me do this first of all. What comes next? No. Come on, drinking games. 1, 2. Thank you. You say fizz bang, and we do fizz buzz. Next. Fizz.
7, 8, 9. Fizz.
2 shots. Fizz.
Buzz. 11. Fizz buzz.
No, fizz for 12. 3 fours. So who doesn't know the rules? You guys have never done drinking games. So the rule is this. If it's divisible by 3, you say fizz. If it's divisible by 5, you say buzz. If it's divisible by 3 and 5, you say fizz buzz. Otherwise you drink. And of course, the more you get wrong, the more you drink, and the more you drink, the more you get wrong. One Christmas, about 20 years ago, God, it was that long ago, we got my father so drunk playing this game that he couldn't clap his hands together. That's a true story. That is a true story. That was pre-kids, I'll tell you. Okay, so we want to code this. By the way, you'll go to job interviews. Okay, if you do job interviews these days, occasionally where they get you to write code. Yeah. And one of the bits of code you get to write is FizzBuzz. Yeah, so you might want to copy this down and say, Kev's, this is Kev's implementation with tests to prove that it works. Okay, so let's see if we can do it. Let's see if Kev can still write code. So how are we going to do this? I've got a simple project setup here. I'm using WebStorm. It's just a JavaScript IDE. Yeah, so whichever one you want to use will all work the same way. Let me go and change the font. Otherwise, you guys are not going to know what I'm typing here. Font. Let's try that. Okay, so what we have in here is this one. Yeah. So I've got this HTML page, which if I browse to, you can go away. It's telling me currently, no tests, no code. Yeah, so we're gonna write some code and write some tests inside here. This thing is pointing at a couple of files called fizzbuzz.js and fizzbuzztest.js. Okay, and fizzbuzz.js is this one, and that's empty, and fizzbuzztest.js is that one, and that's also empty. Yeah. I'm going to start this at least backwards. Yeah, and then so I'll write some code first, and then we'll write some tests around that, just to kick the thing off and get it running. Yeah, and see how that works. So we'll say something like this. And obviously, writing the code, there are many ways of doing this. But I want to say something like var fizzbuzz equals. What I'm going to do is I want to, well, let me write the code and I'll show you what this thing is going to look like. And then I'll explain what it does. So I'm going to create a function here, which is that thing that is going to be executed immediately. Yeah, so this thing is called an IIFE, yeah, an immediately executed function expression. So it basically says, take this function that will be in here, write some code inside there, execute the function, and whatever that thing executes, return into this variable called fizzbuzz. Yeah, this is a module, what's called a JavaScript module. So in here, I'm going to return an object, okay, and that object is going to contain the implementation for fizzbuzz. Yeah. Now, again, I'm going to cheat initially at least. Yeah. So what I want to do here is I'm going to have, I think, two methods. I want a loop method that will return. I'll see what that thing looks like in a sec. And I'm going to have a method called calculate, let's say. And it's the calculate method that's going to do the fizzbuzz work for me. And I'll show you that thing in a sec. So let me set this up, calculate. So I want something like this. I want to say var loop equals function. So this guy, well, I can type it in properly, is going to take a count, let's call it limit. So I want to say, for I equals 1 to limit, okay, calculate, if it's 1, return 1, if it's 2, return 2, if it's 3, return fizz. Yes, that's what this thing is going to do. Yes, loop over the values I give it. Yeah. I'm then going to have another function called calculate equals function. And this thing is going to take a value, and then return something based on that value. Yeah, so the value is 1, returns 1. The value is 3, returns 3. Yeah? So that's what these things are going to do. Now, this is really a private function. Yeah, but I'm going to return, here's a public function so we can test it. And we'll talk about some of those issues in a sec. Yeah, because we don't like testing some public things here. So, in my test code here, well, first of all, what does a test look like? Well, tests look like this, in QUnit. Yeah, so QUnit's got a couple of keywords. So we talk about this in the slide somewhere, yeah, further down, I think. So we set it up using test. Yeah, test has a name, and then we say, this is a function, and we say, here's the name of the test, and inside here, call another function, okay, and inside that function, execute the code that is the test. And inside QUnit, there's some simple things we can do inside here. If I go down to here, we can do OK and say, is the first value true? So if I say OK, true, that returns true. OK, false will return false. And a message to output, if this thing fails. I was expecting something to happen. This is actually what happens. The other one is equal. And with equal, we can do a comparison of two values. So actual and expected. I'm going to get these the wrong way around. Now, I'm almost certainly going to put expected followed by actual. If I do, shout at me. Right. And then there's a deep equals as well, which uses a JavaScript triple equals rather than double equals to do the comparison. So it's doing type-safe comparisons, if you like, on this thing as well. Okay. So what do we want to do then? So I'm being careful not to kill myself on the cables. Let's see how this thing works first of all. So in here, I'm going to say test. Let's just say simple test. And this thing is going to take a function. Okay, and inside the function, I want to say, okay, true equals true, hopefully. Yeah, if that's not right, then things have gone very badly wrong somewhere. Yeah. And if I go back to the browser and refresh this, simple test executes. Yeah, can you guys see that? Do you want a bigger font? Yes, we execute simple test. Yeah. And that's being loaded, remember, just by the HTML page. So I go and look at FizzBuzz test here. I'm just loading up QUnit. I'm currently on version 112, loading up FizzBuzz, and loading up FizzBuzz test. Yeah. So QUnit runs, sees the test code executes, and it executes the test code for me. Question?
It seems to me that you put your test code into FizzBuzz.
Oh, did I put it the wrong way around?
Yeah, that's really in the beginning. What are you doing? So this is your...
I did it the wrong way around. That code should be in here. See, that's the problem with starting with two blank files. And that code should be in there. Thank you. But it still passes, which is a relief. The test method executes, yes. So once the JavaScript loads up, the test method executes. So I'm just calling the code, in here. So that's just a method call. So the JavaScript file loads, that call fires, and that just does just work internally. Yeah. So the QUnit.js file, which is in, I think, probably in lib here, in here rather, that'll contain a method called test and a method called OK. Yeah. So that just outputs some data into the DOM that it looks for, these tests look for, I think, IDs on the DOM that it then uses to update the DOM themselves. Okay, so that's, we see the test running. Yeah. So what we really want then, let's write one simple test first of all, is something like one returns one. Function, Kev. Typing and talking at the same time has never been my strong point. As you can see, like putting things in the wrong file. Okay, so inside here, I have a variable called FizzBuzz. Yeah. And I have a method called calculate. I want to pass that the value 1. Yeah. And that's going to give me back an answer. I'd normally do this in one line, but let's spread it up so you can see what it's doing. Yeah. So I get back, I pass this thing in, I get something back. So my test is going to be, equal. I'm going to get it the wrong way around. Actual expected. So actual is the answer, and I expect to get back 1. When I pass 1 in, it should return 1 to me. If I pass 3 in, it should return fizz to me. Yeah, that's what I'm expecting to see. Yeah, and something like 1 should return 1. Oh, go back to the browser, run the test, and it's going to fail. Yeah. So this is what I mean by test-driven development, right? So I write the test first, and then write the code. Yeah. So the rule says, return the simplest thing possible. Do the simplest thing possible. So what should I return here? Oh, no, let me rephrase that. What code should I write here to make the test pass? Return 1. Yeah, you know what? And that would be the simplest thing possible, right? And the test would definitely pass. Well, yeah, test passes. Return value, yeah, that's probably what I would do, right? So return value. So it says take the value passed and give that back. Yeah. And that would allow that test to pass, which it does. And I guess I could write very quickly, another simple test, which says, 2 returns 2. Blah, blah, blah. Make sure that goes to 2. And then I have another test, and they both pass. That's cool. So what about, so in the code here, well, let's do this test. So 9 returns fizz. Yeah, so I know I haven't changed the text for that either. Just to be anal retentive, make sure I change all the values as well. So the answer should now be fizz. That's going to fail. So what comes next? I got the right part here. Okay. So it's at this point we're going to start doing things like, if value mod 3 equals 0, return fizz. Yeah, then if value mod 5 equals 0, return buzz. Okay, and you write some tests, and hopefully that works. And then we test 15. Yeah, and 15 will tell us that it's going to return fizz. It's just divisible by 3. That's the first thing we hit. So the other test would be something like, if value mod 3 equals 0, and value mod 5 equals 0, return fizz buzz. Not necessarily the most elegant code, okay, but code that should hopefully pass all the tests. So if we just do one, well, make sure that's the 9 one. Oops, sorry. Fizz. Buzz. Cool. So the 9 one passes. We could write some more tests as well. Yeah. But the idea then is to say I've got the test running. I've got the I'll use a test to drive the code. Yeah, so I write a test for divisible by 3. I write for divisible by 5. Write for divisible by 15, and make sure all the code still ran, and then use those tests to drive the code. Yeah. And the key unit itself is actually quite straightforward, right? OK equals, deep equals, yeah, it's equal and deep equal rather. There are methods called equals and deep equals, but they're deprecated. And if you use them, it'll warn you. It'll say you shouldn't be using these. Yeah, so they're still part of the library. Yeah. But actually quite a straightforward mechanism. Yeah. Now, there's a couple of things wrong here. Actually, there's a couple of features I want to talk about first of all. You can group tests together. Yeah, so currently, we have all these tests running one after the other. And I might want to have multiple different test groups for different things that I'm testing. Now, not so much in this case. We have one simple thing. But you can do inside your test code, if I can get to the right page here, something like, module, fizz, buzz, tests. Go to the browser, and we get fizzbuzz tests as the module name on the left-hand side. Yeah. And you can have multiple modules per JavaScript file. Yeah, so the module method call is the thing that delimits whether you're in a module or not. So we'll put another module after this, or halfway through the code here, and give it a different name. Then the first 2 tests will be in the first module, and the second 2 will be in the second module. These are essentially logical groupings of tests. Yeah. But the nice thing about the module is that I can do this. Yeah. We can provide a setup function for the code. Now, the structure of this is slightly odd. So in here, what we do is we define a function. I'm going to get this right. No, we define an object, sorry. I always get this the wrong way around. Inside the object, we define a setup function. And it's that function that will execute before each test. And there's a corresponding teardown function as well. Yeah, so it'll be setup, test, teardown, setup, test, teardown. And it's the module that specifies which setup and teardown function should run around each test. Yeah? So here, for example, well, in this case, we're not really doing anything, but there are occasions with my tests when I want to build, say, a set of objects and initialize those before I run the tests. Yeah, so I would initialize that inside the setup method, then execute all the tests, and then if I needed to, clean them up again inside the teardown methods. And we'll see some examples of that a little later with this thing. And not using this quite the same mechanism, but something very, very similar. Yeah. So modules give us a way of grouping tests, and allow us to put common code in around the tests, which is nice. So that's quite neat. Now, there's something else amiss here, though. If I go and look at my FizzBuzz code, really, I don't want to expose that. Yeah, so currently, I'm exposing the calculate function to the outside world. And the calculate function is it's an implementation detail. Yeah, so how this loop runs, I haven't written the loop obviously yet, but how that loop runs shouldn't matter. It shouldn't care that it's using some sort of calculate function, or I shouldn't care as an outside caller that it's using a calculate function to do this. Yeah. So what I want to do in the loop is something like this, right? I want to say, for var I equals 0, while I is less than, sorry, I want to say from 1, in fact. I is less than 1, I is less than or equal to limit I plus plus. What have I, for var I equals 1. For var I equals 1. Isn't that what I had, or did I do something stupid? Oh, thank you. So talking and typing, right? Just doesn't work. Okay, I want to do something like console.log, let's say, calculate I. Yeah, so if I save that, so I should be able to go into my browser here, if I just refresh this, and run the console. So in here, I've got FizzBuzz. I should be able to do FizzBuzz.loop 4. 1, 2, fizz 4. FizzBuzz.loop. This is the test, isn't it? 1, 2, no. 7, 8, FizzBuzz, 11, fizz, 13, 14, FizzBuzz. And so we print the values out. Yeah. How I do that is an implementation detail. So this thing here shouldn't be exposed to the outside world. Yeah. So really, I shouldn't have calculate here. Agreed? Yeah. Thank you. So yes, Kevin. We've been recorded, guys. Okay, so of course now, if I go back into here, nothing works. Well, obviously the first test, okay, true is true, works. Yeah, but everything else fails. Yeah. So now we have to think, well, how the hell do I test this, right? Because really what I want to test is my public interface. Well, the public interface is the loop method. Yeah. And this comes back to this idea of designing code so it's testable. Yeah. And I find that if I think about designing code so it's testable, it also makes the code hopefully more extensible and more usable. Yeah. So for example here, console.log is hard-coded. Yeah. Really what I want to do here is return, is call some other function. Yeah, so I want in my, what I want to do is this. pass in a callback, and have this called. So the job of my loop is to calculate whether it's the number, whether it's fizz, whether it's fizzbuzz. And the job of the thing that's calling the loop is to process that data in some way. Yeah. And it might be it's going to process it by calling console.log. It might be that it does something else with it. Yeah. So we're going to pass this thing in. This is called a strategy. Yeah, we're doing patterns now. Yeah. This is the strategy pattern. Yeah, so I'm passing in a strategy. I'm saying to it, you do the calculation, tell me when you've got the answer, and I will provide some strategy that deals with that. In the JavaScript world, the strategy is a function. Yeah, it's a callback function of some sort. Yeah. I can then change my test to use that strategy to show that the loop is doing the right thing. Yeah. So if I go back to my test code, what I now want to do is something like this. Let's do this. var data equals array. And let's just have one of these first of all. So when I can't call calculate anymore. We have to call loop. Yeah, so let's call loop 1. Yeah. And I'm going to pass it a callback function. So let's go and define a callback function. Let's say something like var callback equals function. And this callback function is going to take a piece of data. Let's not call it data because that would clash. Let's call it item. Yeah, okay. I'm going to do something like data.push item. Yeah, so push this thing into this collection. Yeah. And now my test becomes, so I haven't got an answer anymore here. I'm just going to call this thing. I'm going to pass it my callback into here. Oh. I'm going to tape over my F1 key at some point. So it doesn't keep doing that sort of thing to me. And then in here, I'm going to say what? Data 1 should equal 1. Yeah? Makes sense? Expected 1, result undefined. What have I done?
Is it data 0?
It is. Thank you very much. Oh, I'm doing everything off one offset, and it is data 0. This is pair programming, right? Fantastic. Yeah. And then we can do the same thing with the other tests. Yeah. So I could turn these all into, and I generalize it and set up slightly differently, with the test code. But we can now write the other tests to do exactly the same thing. Yeah. So data 5, data 4 should be equal to buzz. Yeah. But it makes my code by thinking about how I want to structure the code and having this thing as a private variable. It makes me think, well, in that case, I don't want to hard code into here what this loop does. I want to be able to give it something that can tell me the data, and I'll deal with the data, so I can strategize it. Yeah, and to me, that's one of the great things with testing is that it forces me to think that way. Yeah, how can I make this more general purpose? How can I make this thing testable? And hopefully, it makes the code more extensible. I think not say cleaner, it makes it slightly harder to understand, but certainly more extensible. And I think that's really nice. Yeah. Cool. Are we happy? Questions? We've been going 40 minutes. You've got 50 minutes to go, and then you can go home. Question?
Is there a notation in QUnit, like fluent notation that we have in Unit, where you say, for example, assert that is...
Yes, the question is, do we have a fluent notation? Not in QUnit, no. No, there's no sort of assert that notation. That would be nice. It wouldn't be that hard to write, but no, as far as I know, there's nothing like that. I've never come across that in QUnit, certainly. And I love that notation. If I'm doing NUnit tests, I would use either NUnit's assert.that or even use fluent assertions. Have you seen that? So you can write code which says, value.should.be.5. And it actually extends object rather than just extending QUnit. And that's a really nice way, I think, of writing assertions. Yeah, it would be nice, but I've not seen that for QUnit. It's open source. There you go. Your weekend project. Email me when you've done it, and I'll use it.
Is it possible to integrate Q-unit tests into a continuous integration?
That's a fantastic question. So the question is, can I integrate Q into continuous integration? Are you using .NET? Yes, fantastic. So there's an extension called NQUnit that I use in our project. So NQUnit. So I don't think this thing has been touched for years. Oh, actually, no, I lie. It was upgraded a month ago by the look of it. The last version I looked at hadn't been touched for a while, but they obviously somebody decided to work on this thing again. What this thing will do is in a .NET project, it will wrap your QUnit tests up as if they were NUnit tests and report them back to you as NUnit tests. Yeah, so what I have in my project currently is I have a bunch of NUnit tests, and I use this to wrap up my JavaScript QUnit tests and then run this code on my build server, which is Team City, that does that. And it just all gets reported back in exactly the same way. Now, the only issue with this is that when the tests fail, it's slightly tricky to work out exactly where they fail. You actually know it can be a pain sometimes, but that's the cost you pay for the integration. Yeah. Now there may be. Are you using a build server? Cruise control, right? So maybe. So I use Team City. There may be add-ons for Team City or for Cruise Control that'll do it natively. I don't know, because everything we do is built into Visual Studio, so we do it through that, and that it works happily through there. But if you're not using Visual Studio, then no, but you are, then there's probably an add-on that'll do it for you anyway. Yeah.
I think I sort of vaguely remember something called chutzpah as well.
Yes. Spelt CH, right? Spelled chutzpah, chutzpah. This one, so JavaScript test runner, which I must admit I've looked at briefly, but never really got into. But yeah, it's a Coplex thing. Yeah, and there are other things out there that'll do the same thing as well. Yeah, so chutzpah is another one that'll do integration. I kind of why I stopped looking at this. Probably just didn't have time. But yeah, there are other tools out there.
I got another question.
Yeah.
If cross-browser is a concern,
Cross-browser.
so if you want to support IE 7, 8, 9, Chrome, Firefox, 5, and you wanted it integrated as part of the configuration,
You don't need much, do you?
then you're going to need to run your unit tests across 5, 6, 7, 8 browsers, get the results back.
Yeah.
Fail the build the same
Yeah.
test.
Yeah.
In an ideal world,
Yeah.
I've had a look at trying to achieve that and give up to just run out of time with it.
So the question is, can we do this across browser? And the comment was, you would look and give up. Yeah, me too. I've not found anything satisfying. Now, there are tools out there that'll do integration tests in the browser, like Selenium, for example, that'll take it. But that's more of an integration testing tool anyway. And that'll let you run it in multiple browsers. And even something like Karma, which we'll see later, will let you load the test in multiple browsers. And that might be the way to go, in fact. And that'll just run normal tests. And Karma will run QUnit tests in the browser as well. So wait until we see Karma, and that might give you what you want. But that's more of a continuous testing tool rather than a integration testing tool, as in build server testing tool is what I'm trying to say. Now, whether you can integrate Karma into the build server, you might be able to. I haven't got that far yet, to be honest. I haven't looked at that much yet. But that would be might be the best possibility. But we'll see that in a sec and see how that thing works. Yeah, that's one of the issues with this stuff is that again, it comes back to the sort of different sorts of testing. What we're testing here is unit testing. I don't really care what the browser is. I want an environment to run the tests in. And really, it's browser independent, right? I could use Phantom.js, for example, to run them. We could use Karma, which uses Node to run them, so all sorts of stuff. But if you need tests that are browser specific, then trying to run them across multiple browsers, there are other options out there. Browser Stack, I think, is the one, which will go and let you run. This will run browsers in virtual machines on their servers, and you basically give it the code and say, go and run all this stuff. So you can do stuff on that. So there are things like this. This is a paid-for solution. I think there's trial accounts, you can try this thing out. But I've been looking at this for a long time to try and find the best approach, and I don't know what it is, frankly. If somebody has one, I'd more than happily listen to it, but I don't know what it is. Question? Yeah. Oh, it's an MS one. Not that I know of. That's not to say there's not. I use NUnit, but they might well be. But there's no reason in your code just for QUnit you couldn't wrap it up in NQunit. It'll be reported the same way. Yeah. So, but yeah, there might be an MS test run. Oh, I see. Yeah. So in any unit of MS test, you have that expected exception attribute, or you can do it. No, the way you do it in probably in QUnit would be to throw the exception and do and write the test in line. So you throw have the try catch the exception and make sure and do it in line would be the best way to do it, and return immediately rather than letting it fail through would probably be the best way. That's the way I can think of doing it in there. Yeah, there's no sort of attribute-based expected exception stuff. Yeah. Yeah.
How would you handle within QUnit? How would you handle dependencies on things like Jquery or Knockout? I guess you could say abstract them, but a lot of JavaScript write is kind of testing those technologies.
Let me show you the next stuff I want to talk about, and we'll cover some of this. The question is, how do I handle other libraries, I guess, that are built into this? So let me talk about the next bit first of all, and then come back to. I'm not trying to brush you off, but I want to show you that covers some of that, and then come back to the basic answer, really, I suppose, for QUnit is that, and I haven't done it here, is you just need those libraries installed here that load it, and you use them inside your code. Now, it depends exactly what you want to do with the code. Knockout, for example, which is one you mentioned, is more about data binding within the browser. You're not really writing tests against that here, unless you're writing integration tests with the browser code. Is that fair? Unless you're writing knockout extensions or that sort of thing that you want testing.
Yeah, that's fair. I mean, a lot of JavaScript writing in general is about manipulating UI.
Which comes back to the question about running this stuff inside a browser. Yeah, and that's far more difficult to test, right? So what we talk about testing is the sort of standalone, functionality that they're using rather than the DOM manipulation, which is much, much harder. If you talk about DOM manipulation testing, then you're talking more of an integration testing level. And again, you're talking about using things like Selenium and those sort of tools to test that. Yeah. If you talk about using Jquery functionality for testing, then you can mock that out, which we'll see in a sec. Yeah. But I'm not trying to brush you off. There's just no simple answer to that sort of thing. Yes, absolutely. Yeah, the stuff here is really for testing the logic of the application rather than for testing the integration with the browser. That's not what we're testing here. Yeah. Which goes back to the question about if I want to run this in multiple browsers. For a long time, my aim has always been to have end-to-end testing, right? So I want to test this stuff, which is the unit testing bits, and I want to test the browser manipulation as well. So if I twiddle this bit of the DOM, does this thing go red over here, sort of thing? That is hard to test for a couple of reasons, right? One, it's hard to set up to get the browser to run and load the code and have it all tested properly. But the other thing is that level of testing is so fragile. As soon as you change something in the structure of the application, the tests themselves just stop working.
So what do you do? Fall back to testing somebody?
Yeah.
Run up the browser?
Yeah. That's what we've got. I think that's what we've got to with this stuff is saying we'll have a QA team.
Doesn't Selenium know?
Selenium can do it, absolutely. So Selenium does all this, if you can do it, but again, it's still fragile, right? Even with something like Selenium, and there are tools that wrap Selenium, make it more fluent. I've just found it to be so fragile. And it's not Selenium, it's any UI testing is, whether it's web forms or Swing or WPF, back in the old days, or just standard Windows applications. I've been doing this stuff for many, many years, right? And 20 odd years ago, writing Windows clients, proper Windows C API, SDK, Windows clients, and looking for proper testing tools, looking for UI testing tools, and we had exactly the same issue. You can walk through and record a test, but they're just very, very fragile.
It's an incredibly hard sell in a project to try and set up a UI test suite.
Agreed.
When somebody can go in a browser and go, that looks buttons all over the place.
Yeah.
How do you write a test for that? It's very difficult.
I don't think you can. I don't think you can't, but it's almost better to have somebody there looking at it and running the test manually. And what we do, the project I'm currently on, we have an offshore team that does the testing. They're cheap, right? You know, not the guy. No, I don't know how good the guys are, how bad the guys are, but you know, the company I work for said we're going to offshore it. It's a company in Malaysia. I think we're using. I think it's Malaysia, and those guys, you know, just sit there all day with Chrome, Firefox, IE 8, 9, 10, iPad, Surface, you know, just typing stuff in, clicking on buttons, and reporting back issues. And in the long run, for us, it's probably cheaper to do that. It's a Mechanical Turk, right? You know, Amazon's Mechanical Turk? Yeah, where you want an answer for something, you send a question to Amazon, and the Mechanical Turk is basically 10, 100, 1,000 people around the world that'll go and research the answer for you and give you back the answer. And you pay them in tenths of a penny, or hundredths of a penny, depending on how much work they do. Probably slightly more than that, but you know. Yeah, and it's, so so when people talk about automation, it's automated, but it's automated with human beings. If that makes sense. Yeah, it's a firewall. You push it through the firewall, human beings do the testing and come back with the answers. I don't care if it's human beings or Selenium, frankly. Yeah. Agreed. Yeah, so the comment was repeatability, and I agree. It's, you know, and not just repeatability, stupidity as well is some of the problem. You know, we had guys, this is getting recorded, so I'm going to be very careful what I say here. Yeah. We had guys this week reporting stuff on iPad, for example, that, you know, we're testing an application on iPad, and it can't download documents. It's like, well, no shit, Sherlock. You know, where's he going to download them to, right? There's no file system on the iPad to put these things in, right? Or it can't upload documents only from the images. It's like, well, yeah. You know, so you've got to get past that as well. Yeah.
In Test Manager, you could call the steps, set together to code.
Absolutely, but again, it's fragile, right? Because if things change, tests will break. Yeah, and fragile tests are, in many ways, I think, worse than no tests. In many ways, because people then just don't fix the tests, and the tests then become ignored. You know, you turn them off. You know, so and that's as bad as having no tests at all. At least as bad as. Yeah. If there was an answer to this, guys, I would give it to you. I swear. And I've looked and looked and looked. I'm sure you guys have as well. Right? And I'm not saying there's no answer. I've just not found one that I'm happy with for these things. And in fact, 5 years ago, I worked at Confused.com in Cardiff, and Confused had a QA team. You know, I'm a developer. I hate who works at QA teams here? Anybody? I hate QA teams, right? No, in the nicest possible way. Yeah, they're great mates. But you know, you throw them an error, you throw them an exception. So you throw them code, and they come back with a bunch of errors. Yeah, and it was a pain. Yeah, so I've constantly railed against QA teams long before that. You know, everything should be fully automated. All tests should be fully automated. But the last few years, as I've tried to do more automation of UI testing, I've slowly gone, you know what? In some circumstances, you know, those guys are worth their weight in gold. You know, because there are things that are just hard to automate. You know, as much as I'd love everything to be push button and everything is tested, I don't think we're quite ready. We're quite there for that yet. Yeah. I'd love to be proven wrong. I really would. Yeah. Anyway, moving very swiftly on, otherwise we're not going to get through half of this. Okay, so one issue that we have with testing is this one. Let me go and grab some code out of here rather than write the stuff by hand, just to save a little bit of time. Let me go and grab this bit. So, and then explain what I'm going to do. So I go into my blog here, and put this thing in, and then browse to okay, so again, what I've got here is a blog test HTML, which just includes some, in this case, some jQuery code. Oh, got that included twice. So we're using jQuery here, and we've got this blog.js and blog test.js. And did I put the code in the right place this time? I did. Okay. So here, as a simple example so far, I've got a function. I've got a variable called blog posts. Blog posts is a function called get posts. When I call this thing, it's going to reach out to the server. Yeah, we haven't done that bit yet. So it'll reach out to the server, pull back some data, and then call this callback. Call the callback function. Yeah. And in my test, I want to prove that the callback has been called. Okay. Now, we could do this ourselves, right? So what I could do is in blog test.js is something like this. So I think about this. callback is called. It's going to be a function. So in here, I want to say, well, blog posts dot get posts, and this thing takes a callback. Yeah. So I could have something like var is called equals false. Var posts callback equals function, and just say is called equals true. And then in here, do something like OK is called. Callback was called. In fact, before I do that, let's just show the test failing first of all, red first of all. Yeah. So if I go and refresh the page, test fail. Yeah, callback was called, wasn't called, it was set to false. If I go into here and uncheck that and say, oh, I didn't pass the callback. Yeah, so pairs. I love the test works, absolutely. Yeah. That's what I was trying to say before I got confused myself. So I want to pass post CB. Oh, post CB. That one. Yep. Now it works. See, I knew that all along. Okay. This thing here is called a stub or a mock or a dummy. Yeah. It's not the real callback function, right? I don't want this thing to do the real thing. Yeah, it's just something I'm using for the tests. Yeah. And the more tests I write along these lines, the more of those little sort of stub functions I'm going to end up writing that do different things, right? It might be that this callback, do I do that here? It might be that I want to pass this thing. So var data equals something like this. I'm going to pass that into the callback. Yeah. So I might have another test which says something like callback was called with the correct data. Yeah. So now what I might do is say something like, post callback was called helper for that one, and then have something like it was called with correct data helper for this one, and then in here pass that thing in, and then in here do something like, you pass the data and somehow compare the data, change it. No, so I end up with, if I've got 30 tests, maybe 30 helpers. Yeah. And that gets very messy very quickly. Yeah, even with 2, right, it's awkward. Yeah. So what we'd like to have is a mechanism by which we can do that ourselves. Yeah, so let me go back to the start of this set of slides here. Yeah. So we have this idea of what are called doubles, where we want to substitute some piece of code for something that already exists. Yeah. And the piece of code we're substituting in is exactly the same as the thing it expects, but it's not the real thing it expects. Yeah, it's a fake for this sort of stuff. Yeah. And there's many reasons for doing that, right? So one is just checking callbacks, as we just saw. That's a good reason. One is the code I'm calling wants to hit the network. Yeah, so in JavaScript, if I'm writing client-side JavaScript code, that's going to be the place, right? I'm calling $.ajax or $.post, or I'm using SignalR to make a callback, or something along those lines, right? And I don't want to make that call because it's a unit test. And this code is running on a build server somewhere that has no access to the real web server. Yeah. So I don't want to make that real call, but I want to prove that call actually happens. Yeah. So we can use a double for that instead. Yeah. So we want to replace the real call to .ajax with our own call to .ajax, our own fake to it. If you're running in NUnit, if you're running server-side code, that sort of thing, then file access, database access, anything that requires an external resource, we want to replace with something. Yeah? And that's where this idea comes in. So there's a whole range of these things, different sorts of these. Yeah, there's a fake. DOC is the, I'm going to get this. So SUT is the system under test. DOC is, I can't remember what it stands for. It's basically the original object, the original component. Yeah, so it replaces the original component. Yeah, but I can't remember what doc actually stands for now. Mine's gone blank. Yes, we can replace it with a fake. We can replace it with something called a stub, so you can pass different options. There's a whole range of different things that all look very, very similar. Yeah. Generally, you hear these things generically called fakes or doubles or mocks is the term you'll see most often for these, I think. Yeah. Although mock has a specific meaning in this scenario, but you'll hear these things generally called mocks. In JavaScript, this is really easy, because JavaScript is dynamic. Yeah, so I can walk up to a JavaScript object and go, you know that function you've got called Ajax? Well, replace your implementation with mine and just plug it into the object. Yeah, and just replace the one that's on there already. Because every JavaScript object is a dictionary, right? So it's a collection of name-value pairs. And function names on an object are just the name in the dictionary, and I can just go and put another value in there. Yeah, so changing, putting out a real implementation and replacing it with your own in JavaScript is trivial. Yeah, which is good. Yeah, so good to be able to do that. And we could do it ourselves. We could write our own. Every time we want to create a mock or a double or a fake, we could do that ourselves. Yeah, and we sort of did that in the previous example, but it becomes messy. Yeah. So there are libraries that help us do this. Yeah. And Xenon is one of those libraries. Yeah. So Xenon lets me create spies, mocks, fakes, doubles for the things I want to use. Yeah. But more importantly than that, it also lets me check properties on them as well. So I can walk up to my spy and say, were you called? Yeah. Were you called with this value? Yeah. So the example we saw was this. Yeah, so we took the blog post, we call it with a callback, yeah, and I can use, rather than creating my own dummy function, I can use Xenon instead. Yeah. So I can say callback equals Xenon.spy, and that gives me back an object here, and I pass that into my function instead. Yeah. And then, so Xenon this will get called by my function, I hope. Yeah. And if it is called, just sets a property in itself, saying, yeah, I was called. Yeah. So let's go and do that.
So wasn't it easier to look at the XHR?
To test the...
Yeah. Sorry?
What was the question, sorry?
Wasn't it easier to get if it's code, for example, for an Ajax code, to look at the XHR response codes?
Is it easier to... Sorry, I missed that. Say it again.
To see, if, for example, if I get a destination call, if that gets called, I can use the XHR.
But the XHR response code implies that you're calling the remote server.
It's only for non-coding.
Yeah? So we don't want to do, right? Yeah? Yes, the question was, can I look at the XHR response code? Yes, is the answer, but that implies you've called the remote server, so there wouldn't then be a unit test. Okay, so what I can do in... Depending on the component in the sense of... Oh, thank you. Dependent upon component. That's it. Thank you very much. Yeah. I'll catch up with you guys in the end. It's okay. Yeah. So I want to get rid of all this. Okay, and get rid of that for now. Okay. So now what I want to do in here is do something like var callback equals signon.spy. So go and create me an object, a spy object that I can use. I then pass that spy object into here, and then my test says callback.called. Yeah, and that should be set to true if it was called. Should we do the same test as before? Don't pass the callback in, so the test should fail. Hang on. Let's get going first of all. And the crowd goes wild. Question?
Yeah. How does Simon know that it has a property called callback that should be set to true?
It doesn't. All I knew with Simon is saying, this says create me an object that I pass to here. Create me a function, essentially, I pass this back. I pass that function into here. This thing calls the function, and when that function is called internally, it says a property in itself saying, yeah, I've been called. Yeah. So Simon doesn't care what the caller looks like. He just says, I'll just deal with anything you give me, basically. That make sense? You don't look convinced.
Right. As I get it right now, get post sets next group call.
No. GetPost just calls that function.
So can you get rid of dot calls on your test?
It's part of the sign.
It's part of Signon. So Signon creates me an object. Yeah, Signon creates me a function.
Which is not static, I can't pass
called?
Core property.
Which was my original question, whether it has attribute called call.
Oh, sorry, sign-on does, sorry. So this property here is a property of the sign-on spy. Sorry, I didn't understand the question, my mistake. I apologize. Yeah, so this property here is a property of the sign-on spy. So I pass that spy into the callback. When my get post calls the function sign-on is created for me, that function internally sets that property to true. Yeah, and if it wasn't, it's set to false initially. So it's going to look something like this, right? So that spy will look something like something like that. I mean, not that exactly. It just says I'm a function, set my property myself to true, and then here I can look at the call property. It's just creates an anonymous function for me. It was the same as me having a global variable say, I was called. It's a property of the function. Remember, functions in JavaScript are objects, and functions can have properties on them. Yeah, and that's what it's doing. Now, the other thing Cylon lets me do, if I go back into here, I'm going a bit quicker here, so I want to get to Jasmine and Karma as well, is it'll let me do things like replace the Ajax call, for example. Yeah? So if inside my getPost function, we want to do something like, where are we? So rather than saying data here, actually let me leave that there. I want to do something like this. $.Ajax. Okay, and this thing takes a JavaScript object which has a URL, which is going to be, blog/posts. Yeah, and then some other stuff as well, like a success function and so on and so forth. Yeah. So if I was doing this in the browser, if I loaded this code into the browser, Jquery would load. Yeah, so $, is my Jquery object. Ajax is a call on Jquery, and that Ajax call says take that URL /blog/post and send a request to the server. Okay, in this case, I'm not changing what the type is, so it sends a GET request to the server and pulls back some data. When that comes back, it'll execute this function here, okay, to say, yeah, or return me a promise object, or however you want to set this thing up, and do some work on that. Yeah. Now, in a unit test, I don't want that to happen. I don't want my code to call the server. Because it might not be a server. If I'm running this in a build server, or it's going to be slow, or all those other things. So I can use sign-on to replace the Ajax call for me. Yeah. And again, let me go and rip the code off because I'm going to forget what this thing looks like otherwise. So in here, if I go back into my test, I do this all in one test. Normally I have these as separate tests. Yeah, but let's just do it all in one test just to make my life slightly easier with the typing in here. So what this says is stub out Jquery's Ajax method. Okay, so replace Jquery's Ajax method with your own internal implementation of this. And again, it doesn't care that it's the Ajax method on Jquery. Right? It has no knowledge of what the underlying thing I'm replacing is here. All it's going to do is look at the Jquery Ajax method and replace it with its own function. It's going to do nothing, essentially, in this case. Yeah? And I say, when your stub gets called, return these values. Okay, so when I call Ajax on Jquery, it returns success as the first parameter of the call to say everything worked, yeah, and it returns some data to me. I could put fail, okay, and then check it that way as well. But I'm testing the call I'm making. What do I do when that call succeeds? Okay, is what I'm looking at here. Yeah. And then what I can do is I can go and look at this. Yeah, so I can say, was it called? Yeah, it was called. And then I can look at the, again, let me go and stick this thing in here. So we made the call. Okay, we can then say, when the thing I'm testing made its call to .ajax, did it pass these parameters? Okay, so /blog/post, is that what I typed in? Yeah, so I'm passing in this object here. So was it called with that parameter? Yeah, first of all, so am I passing the right thing in? And also, the callback function that I've defined here was that called with the right data that came back? So we're returning from here 1, 2, 3 in an array. Did I pass in 1, 2, 3 here? Yeah, to get this thing to work. Now, this test should fail. This test should succeed, I hope. This test is going to fail. So I've done nothing with that data that comes back yet. Yeah. So probably what I should do in here is do something like success, callback, success function that takes some data. I should probably do this in one line, actually. Callback data. So call the callback function with the data. Get rid of that guy. Get rid of that guy. Yeah, so call out to the server. Here's the URL to use. If it succeeds, call the callback function that's been passed into me, passing in the data. And Xenon should mock all this up for me, and this should all work. You know that's going to work, right? You don't need to see. 3 tests, 3 passed. Yeah.
Just wondering, so when you're verifying that the callback was called with so like an array of parameters.
Yes.
Does Simon, when it does the call with match comparison, does the ordering matter of the parameters, or will it just kind of compare each of the kind of name values within that collection?
So you're asking. So the question is, if I can go back into the code here, does this order here matter? Or does this order matter?
Yeah, so it's like if you pass, so if you call it with like
Let's
URL
try.
and then some other parameter there, but then in your test you specify that the other way around, so you put food first and URL second.
So the question is does that work?
Yeah.
That's FizzBuzz. That's not going to work. Still says 3 there. So let me get rid of these things, just not to confuse myself. So that still works. I'm not convinced. I'd like to see my test failing before I see them passing. So that fails. So yeah, the order doesn't matter. It looks like it's walking through and checking the name value pairs in the dictionary, which sort of makes sense. Right? Actually, order shouldn't matter.
Does the sign-on stub then get cleared once you or
that is a great question. So the question is, does the sign-on stub get cleared? No. So I've commented it out here, but there's a .restore call. You should do xenon.restore and say, put it back, please. Yeah. And if you don't, if you don't put it back, it means every test has access to that, to the stub, which is something you want. That's something that's exactly what you want. Yeah. But occasionally what you'll do is that when a test runs, you replace the Ajax call with the stub, and then the next test you replace the Ajax call again with the stub, and it'll go, you can't do that. You already replaced it once, and I'm not going to let you do it again. So it detects it's already been replaced. So you'll find that you tend to have startup code which does a replace, and teardown code which does the undo. Yeah. And we'll see that in a sec. We'll do that in Jasmine, in fact, in a sec. Yeah. So we'll see exactly that. So yeah, thanks for that. So the Ajax, you can stub out Ajax, and that's fine. Yeah. The problem with that is that suppose you go along at a later stage and change the, that should work again. Change your blog code, not to use Ajax, but to use post, for example. Yeah. Or to use some other mechanism to go and get the data, yeah. Which may or may not work now in this case. Yeah. Without you changing the test again. So what Xenon lets you do is to replace the underlying XHR object. Yeah, which then goes back to something you asked earlier. So I'm not going to write this code. Yes, on the slides. Feel free to play with it. And basically, what this gives me, it'll work in a very, very similar way. It's more complex to set up because I'm dealing with this sort of HTTP level stuff now. So I've got to say things like, when this thing gets called here inside my setup code, I want to create the fixed XML request object, and when somebody calls create on this thing, do this. Push this request object into some collection for me, and then down here use the request objects. It's hard to set up. There's no doubt about that. but it gives you a better abstraction. You're not relying on .ajax, you're saying any XHR call, okay, can abstract away. Which one to use is up to you. If you do the Xenon specs, the documents rather, they recommend using this. Yeah. You tend to shy away from this because it is trickier to use, but it does give you a much, much better abstraction than just using the Ajax call. What I would tend to do, if it was me, is to get the Ajax one working first, and that level one working first. And then if I wanted to come back and replace it with this. Make sure it all works, and then replace it so you know the code is working. Because this stuff is just slightly trickier.
So is there any kind of finalize function? So I have a setup function.
There's a teardown function as well. Is that what you meant? So here, I'll show it in. Yeah, so setup and teardown, the corresponding pair. Okay. You guys got nowhere to go, right? Actually, Thursday's the new Friday, isn't it? So Thursday night is night out. Where are we going, guys?
London Cocktail Week.
Sorry?
It's London Cocktail Week.
Is it London Cocktail Week? Oh, yeah. Fantastic. Where are we going? Okay, so I want to show you two more things. Let's see if I can get time to write code. If not, I'll show you some code that does this anyway. So there's a JavaScript library called Angularjs. Any of you guys using Angular? A couple of people. Okay. Yeah, me too. I think Angular's great. I love Angular. And it lets you write single-page applications, JavaScript single-page applications. Yeah, it's an MVC framework for building these sorts of apps. And it's fairly complex and lots and lots of JavaScript code to get all this thing going. And the Angular guys for testing use a couple of things. They use this tool called Jasmine, and they use Karma. Which was this thing used to be called Testacular. And the guy that wrote Karma, Vojta, I can't remember the guy's surname. He works on the Angular team, and he was a student in Prague, I believe, where he wrote this thing as part of his computer science degree. Yeah, he wrote Angular as part of his computer science degree. Not Angular, sorry, Karma as part of his degree. So this is where this thing has sort of become more well known from that sort of area. Yeah. So Jasmine is what we call it's what's called a behavior-driven development test framework. Yeah, so with QUnit, you do OK and assert and that sort of thing. This will let you do the same thing. Jasmine will let you do the same thing, but the way you write the tests is more descriptive. Yeah, so it's sort of defined. I should have put this in quotes. It's defined in English. Yeah, so it looks something like, well, the setup's more complex. I'll show you the setup in a sec. Yeah. But the tests look like this. You start with a describe statement, which says, I'm going to describe what these tests look like. Yeah, so that's your top level thing. Yeah. And again, you pass it a function. Yeah, so you pass it a name at the top level and a function. It's the function that then executes. And inside the function, this is where you get more of the fluent sort of API, if you like, in many ways. Yeah. So you have tests look like it. Yeah, so that's the test, the equivalent of test from QUnit. Yeah. So we say it, and in this case, quotes is defined, and you pass it a function. And that function then executes. Yeah. And it's inside here, you execute what are called expectations. You're not doing asserts anymore. You're expecting something to be correct. Yeah. And in this case, all we're saying is that this thing, whatever it is, rsk.services.entries, whatever that is defined. Yeah, so that's the top level thing. I have one of these. And then when you have one of those, you can then start running tests against, start running more expectations against that. Yeah, down through this thing. Yeah. So let's go show you some code in here. Off we go. We have 10 minutes, so let's see. What's the best way to do this? Let me show you the stuff in here for the setup first of all. So I've got the specifications. So this is a Jasmine. This is a Jasmine HTML file. Yeah. You typically call this thing Spec Runner. So these things you're running are not generally called tests. They're called specifications, which again goes back to this idea of having tests define what the spec for this thing should be. Yeah. So you set the specifications. Yeah. So you have this thing called a Spec Runner. And this thing, we basically bring in all the libraries that we need. So we bring in, some Jasmine style stuff, some JavaScript stuff. There's an HTML helper here, and the HTML itself is empty inside. It's just a body element, nothing else. And the code here kicks off Jasmine and then runs the test, and as the test executes, updates the HTML with information about the test. Yeah, and that's what this HTML reporter guy here does. Yeah, so it runs the test in the right order. To create the test, say you start off with this describe thing. So you'd say something like, where's my test gone in here? Describe. This thing would take a string. Let's do something like blog. What did I call this? Blog posts. So blog post is defined, which will then take a function. Quotes takes a function. Okay. And then inside here, you have the it statement. Yeah, so it is defined, which would also take a function. Okay, and then this function would have the expect in. So you'd say expect blog posts dot to be defined. Now, oops, didn't want to do that. Assuming this is all set up correctly, if I go and browse to the file, it looks something like this. Yeah. So it comes up and says, passing one spec, blog post is defined. Yeah. So I should probably say something like here, blog post. That's what I'm looking at. And then is defined. Yeah. And then other specs will run underneath that. So I can then start doing things like, making the same test I run for key unit with using Xenon. Was it called? It was called with the correct data. I'd write those as specs underneath here. We've only got 5 minutes. Let me go and do here's one I prepared earlier, just to show you exactly what this thing would look like. So if I go to, where's it gone? This one I think I want. Blah, blah, blah. This one, yeah. So here I say, is defined. So expect blog post to be defined. And then we say, calls the server with the correct URL. So I do the, was Ajax call.match with the URL? Was it called with the correct data? And so on and so forth. So if I go and, let me just go and kill that off a sec. I don't want us to be confused. And browse to this one. Open in browser. There we go, cool. Yeah. So the dots at the top are the number of tests that have run. Yeah, so it's run 4 specifications. Yeah. So blog post is defined, calls the server with the correct URL, callback to be called, and to be called with the correct data. I probably should name those slightly differently. So these things, notice, are nested. Yeah, so blog post and then the callback inside that. So what I can do inside Jasmine is I can nest describes. So a describe can contain another describe, it can contain another describe, and so on and so forth. Yeah. So I can start at the top level and write expectations for that, and then say within that I show these expectations, and within that I show these expectations. Yeah, then nest them down. Each set of describes has its own setup and teardown functions. Okay, before each, after each, they call it in this case, which are more descriptive names, right? So before each spec, after each spec. Before each spec, after each spec. So here what I'm doing is before each one, I'm setting up the sign-on stub. After each one, I'm restoring it again. Yeah, which goes back to the question I was asked earlier about how do I put this thing back. Yeah. And then I run the spec. So then each spec, the code themselves inside here is essentially the same as the key unit tests, right? It's just done in a different way. Yeah. But it's more descriptive of the code. Yeah. I prefer this. Yeah. Now, I've only just started, I haven't been using this long. I've been using this a couple of months, Jasmine. I've used QUnit for a long time. This is a couple of months I've been using it, but I do prefer this. And part of the reason I prefer this is I can give it to my analyst, my product owner, and say, are these tests, no, not at this level maybe, but at a different level, are these tests what you expect to happen? Yeah. But sorry? The answer is yes. So the question was, can I run in TeamCity? The answer is yes, although I haven't done it yet, but there is a TeamCity plugin for Jasmine that will let you run this, but I haven't installed it yet, but yes, you can. Yes, you can. Now, the other thing I wanted to show you, sorry, I realize I've got to the end of this quite abruptly here, is this. If I go to Okay. So there's one other thing that comes along, well, not comes along with this, but you can use with this as well. Oh, the other thing, Jasmine is its own spying system as well, which I haven't used because I've been using Xenon. Yeah, but Jasmine has spies as well, so you can use. So if you just want one single framework, you can use the Jasmine stuff. Yeah. Now, the other thing is this, Karma, yeah, and I love this. So Karma is a Node extension. Yeah, so you do install Node, if you're running on Windows or Mac or Linux, installing Node is trivial on all those platforms. Yeah, so Node.js. Then you can install Karma, and you install it by this. So you use npm, which is Node's package manager. So node npm install Karma. -g just means global. Yeah, so global says it's now available anywhere. Yeah. So I already have it installed on my machine here. Yeah. So I do npm list, -g list, I think I want. Yeah, so Karma's already installed. Yeah. What you can then do is in the directory where you want to run the tests, you do npm init. And now init will create you a configuration file. Yeah. You can give it the name of the file, which is what we're doing here, or you can say to it, use your default config file name. And it'll create one thing called karmaconf.js as the default one. Yeah. And the configuration file, well, if you run npm init here, actually, let me go back and do it in the, where you were just now, prep testing, demos, testing. Here, so I do npm init here. Yeah. It comes up with a bunch of questions for me, yeah, which says, not npm init, wrong init, Karma init. Thought they were the wrong questions. Again, let me Control-C that, clear the screen, and do it again. Okay. So it comes up with a bunch of questions for me. What testing framework? And it's supposed to number. Yeah, we're using Jasmine. Okay, hit enter. I'll be using require. I'm not using require.js here for this code. Yeah, but if you hear it would wrap all this up as requires and use the module system. No. What browsers do you want to test this thing in? Now, this will run the test in the context of a browser. So the browsers get launched, and it runs all the tests inside that browser. It's not going to launch your HTML, yeah, but it will run the tests inside the browser for you. So you can pick Chrome. If I hit tab, Chrome Canary. If I get Firefox, Safari, so there's a bunch of these things that'll let you choose. Yeah, and it'll create an array of these to run them inside. Yeah. I just want to use one here. We'll see this thing fire up inside Chrome. Yeah. Where do the files live? Yeah, so you can say my JS files live here, my test files live here, and so you can give it a bunch of file patterns to go and load the files that it needs. Yeah. So we won't do anything in this one. Do you want to watch the files? Yeah, so I'll rerun this thing automatically, so we say yes. And then what you end up with is a configuration file which looks something like this. Yeah. Now, I've added to this as well Jquery, because I'm using that in my code, and Xenon. Yeah, there's a blog.js and where the specs live for this guy, and then all of the other, where the browsers are, yeah, and, standard config for Karma. Yeah. What you then do is you run Karma start. You either give it the name of the config file, or it'll use the default one. Yeah. So if I go back to the testing here, and then just clear screen and do Karma start. Fires up Chrome, okay, and then runs the tests. Yeah, so executed 4 of 4, success. So the tests have run. If I go back into my project here and go to blog.js, in fact, make sure I'm in the right tests here. No, I'm in the prep one. Yeah, I'm in the right one. Okay. Spec I want, this one. So there's the specification that we had, and this is what I'm testing. If I change one of these files, so I change that, and flip back to the console window, tests have run. Yeah? It's not telling me it's failing. If I go back and put it back again, test run. And if you watch Chrome in the background here, if I go and just drag this thing out of the way and change something, yeah, notice Chrome flashes. It's just running the test inside Chrome. If I had multiple browsers, it would run them in all those browsers, specified, across the world. If I go and add another specification, or go and change the specification, Okay, again, the test run and pass or fail. So it's running continually in the background. Yeah. Now, WebStorm, that I'm using here, has a Karma plugin. So you can run it inside WebStorm. Well, I haven't got that installed here. Yeah, so there's a plugin for Karma that just run the tests inside WebStorm. So you don't even need a separate window to go and run these things in. Yeah. It's great, right? So as you're adding tests, as you're, adding new functionality to the code, because JavaScript, there's no compile step, right? If I'm running Visual Studio and .NET, you Control-Shift-B, compile, and that's part of the compilation. It'll run the tests, yeah. Or you go if you've got resharp or right-click and run, and whatever it be. It's just doing that here in the background. And I think that's fantastic. Yeah. So you're getting constant feedback, okay, as to what's happening. Yeah. And my choice today would be to use Jasmine, Karma. Obviously, I don't need WebStorm, yeah, to run Karma in the console, right? The only thing I've done, and I did this last night, was this is conemu, the console, not command.exe. And the reason I chose this, and you can't see it very well because it's quite washed out, but you can see it if you saw my screen here, is that the colors on there on my screen are actually very bright. So I've changed green to be a bright green and red to be a bright red. If I run this in command.exe, the colors are very muted. And it's really hard to see exactly what's, even to read the text. Yeah, so again, if you're running on Linux or Mac, you're fine. You can just change the colors inside the console anyway. Yeah. So you might want to pick a different console terminal emulator to use rather than CMD. PowerShell might, I don't know if you can do it in PowerShell, as in change the colors the way you want to. Yeah. But you can in this guy. Yeah. But apart from that, you need nothing else apart from a text editor, Node install, which is a trivial install, and run Karma. Yeah. And I think it's a very, very nice tool. And much simpler setup than I thought it would be when I first came across this thing. Questions?
From a continuous integration standpoint, obviously Jenkins gets it. Is it possible to run the QUnit tests?
It should be, yeah. I've not. Certainly, a lot of the build servers will have QUnit plugins that'll let you run the test automatically. I don't know if Jenkins does. I would think it does, though. I would think Jenkins, Cruise Control, TeamCity, TFS. I would imagine so. Yeah, I don't see any reason why not. And the same with the Jasmine ones as well. They kick off. If not, it'd be a simple matter of running. Unit for QUnit. Yeah, I'm trying to think if you could run a script. You might be able to script it, but that'll be a bit more work. But I'm sure they have plugins for the same that'll do it. Yeah. I'm really sorry. I apologize for rushing the last bit, but it was because we got so caught up with the earlier stuff. Any questions? One more.
EXTJS.
Yes.
Much interaction with that?
I haven't, unfortunately. I've used Jquery a lot, but EXT I haven't used. No.
Ajax mock? The library?
No, don't know that one.
Or is it mock Ajax maybe it's called, is it?
Oh, the mock library.
Yeah, for mock-up. It's a mock library for mock.
Right. Okay. Yeah.
Have you used that? And compared it with the Sile?
No, the ones I've used is I've used Xenon, I've used the Jasmine ones, and if I'm writing Angular code, there's an Angular mocks library as well. I've used that, but I haven't used any of the others. No. Yeah. Again, there's so many of these things, right? No, sorry. Okay, let me just put up the front slide again. So if you have any other questions that you haven't had a chance to ask, then it's kevin@rocksolidknowledge.com. Put that one, stick that up. I'm doing a full day JavaScript talk tomorrow. If you guys are going to come back to that. If not, thank you. Hope you enjoyed it.